And welcome to Technology Tap. I'm Professor J. Rod. In this episode, we're going to talk about other operating systems like Linux. Let's tap in. The moment you leave Windows, most people realize something uncomfortable. That they don't really actually understand computers. That they understand interfaces, they understand buttons, they understand menus and where to click. But they don't understand what the system is actually doing, why commands exist, and how the OS is structured. And Linux exposes that immediately. Welcome back to Technology Tap. I'm Professor J. Rod. I love helping students pass their A+, Network Plus, and Security Plus CompTIA series of exams. I'm also like to dabble into technology history. I'm an author of Scam Proof for Seniors, which is available on my website, professorjrod.com/books, and it's also available on Amazon. You can reach me in all sorts of social media, TikTok at Professor J. Rod, Instagram at Professor J. Rod, Facebook, Technology Tap Podcast. And today we're stepping into something that separates users from technicians, because supporting multiple operating systems is not about memorizing command. It's about understanding how systems think. And Linux is the best place to start because Linux does not hide anything from you. When most people first open Linux, they feel lost. There is no smart menu, no familiar layout, no click here to fix it. And that's not a weakness, that's the design. Linux assumes something very important. You are responsible for the system. Linux is an open source operating system that provides direct control over systems operation, command line interaction, and flexible configuration across environments. Unlike Windows, there is no single standard interface. There's no assumption of simplicity, and there's no protection from mistakes. In enterprise environments, servers run Linux, security tools run on Linux, and cloud infrastructure run on Linux. So when you learn Linux, you're not learning another operating system. You're learning how systems are actually controlled under the hood. In Windows, actions are often click, confirm, and done. In Linux, actions are command, intent, and consequences. That difference matters because Linux forces you to answer, what exactly am I trying to do? At the center of Linux is something called a shell. A shell is a program that interprets users' commands and communicates with the operating system kernel. It is not visual, it is not decorative, it is functional. And this is where many students struggle. Terminal is what you interact with. Shell is what processes your command. You open a terminal, you type ls in the command. What happens? The terminal sends input. The shell interprets ls. The OS executes the command, and the output is the return. And ls is like dir, right? List structures. Why this matters? Because when something breaks, you're not clicking around hoping. You are issuing instructions to the system. Linux commands are not random. They follow structure. Command plus options plus arguments. So here's an example. Command, the action which you want to perform. So the example will be ls. The options modifies the behavior. Example, if you type -L right after ls, you want detail view. And the argument, you specify the target. Example /home. So full example will be ls space -l space /home. This means list files show detailed information in the home directory. Now, why does this matter? Because if you misunderstood or misunderstand the structure, you just don't get the wrong results. You can modify the wrong file, delete the wrong directory, or break the system. Linux is also case sensitive. Case sensitive means upper and lower case are treated as completely different values. File.txt with capital F is different from file.txt with lower f. They're two different files. A student runs cd space documents, but the folder is documents with a lower d, results failure, not because the system is broken, because precisions matter. One of the biggest mistakes new technicians make is that they try to fix things before understanding where they are. Where am I in the system? Linux has a command called PWE, which is defined as print the working current directory, or print the working directory, right? So if you type in PWD, it should give you what directory you are now at. Because without context, you're operating blindly. Another example, CD, right? You should be familiar with that. Changes the current directory, right? So if you want to do CD space /etc or etc, it moves you into the system configuration directory. Again, ls, right, gives you a list of contents of a directory. ls space -l shows full permission, ownership, size, and date. A user comes up to you and say, my file is gone. A user guesses. You, as a technician, verifies. You go to the computer, you do PWD, you want to know what working directory you're at, you do ls, cd space home, cd space /home /user, ls, cd documents, ls, right? You're not searching randomly. You are walking the file system logically. Now that you know where you're at, you must understand how to change things. You have your cp command, which is copy files, right? You can want to do, for example, cp space file.txt space backup.txt. MV is moves or renames the file, right? For example, you want to mv space file.txt space /home /user directory. RM deletes the file permanently. Linux does not protect you. There is no undo, right? RM, once you use it, it is permanent. So if you use RM space -R -F space /, this deletes everything. Not theoretically, actually. Linux assumes if you type it, you meant it. Large systems contain thousands of files. You don't scroll, you search. You have your find definition, your find command, which searches for files based on criteria. You have your grep command, grep, searches inside files for patterns, right? You might, for example, you do grep error system.log. This extracts only lines containing the word error. Why this matters? This is how you analyze logs, detect breaches, and identify things that are failures. File system. A file system is the structure used to organize and store data on a system. In Linux, / is the top of everything, or they call it root, the root directory. Everything branches from root. Home, etc, var. Why does root matter? Because understanding structure means you know where the problems live. Mounting. Mounting is attaching a storage device to the file system so it becomes accessible. Without mounting, the system cannot see the drive and the data is inaccessible. So for example, etc fstab or etc /etc /fstab defines how file systems are mounted at startup. Why does it matter? If configured incorrectly, drives fail to mount, systems fail to boot correctly, and data becomes unavailable. At this point, something has happened. You move from I know commands to I understand why commands exist. You now understand how Linux receives instructions, how files are structured, how systems are navigated, how actions have consequences. And now we move to the next layer. All right, just because you can access something, should you be allowed to? In Linux, they have a lot of control. Because control without restriction is not power, it's a risk. In the real world, multiple users share systems, sensitive data exists, and critical files must be protected. So the system must reinforce something, boundaries. What are permissions in Linux? Permissions are rules that define who can access or modify files and system resources. Without permission, any user can delete system files. Any process could modify critical data, and mistakes become catastrophic. Linux security is built on two simple questions. Who are you, and what are you allowed to do? Users, the first layer of control. What is a user? A user is an account that represents a person or process interacting with the system. Not all users are equal, and Linux makes that very clear. What kind of users are there in Linux? They have the root user or the super user. You have your regular users and then service systems account. Root user is absolute control, right? Root is the highest level account when unrestricted system access. Root can modify any file, install or remove software, change system configurations, shut down or destroy the system. Why is it dangerous? Because root has no restrictions and no safety net. Again, so a technician runs rm space, that's remove, right? Rm space minus rf /var/log as root. All the logs are gone. There is no undo, there is no warning, there is no recovery. Root is not for inconvenience. Root is for precision, intention, and necessity. Regular users have controls with limits. A regular user has limited access to protect the system from accidental or malicious changes. Regular users cannot modify system files, cannot install critical software, and cannot affect other users. Why does this exist? Because the most damage is not malicious, it's accidental, and I've seen it. You can accidentally do stuff. So now we have a problem. Regular users are safe, but sometimes you need to install software, modify configuration, or fix system issues. So who do you give power without giving full control? The solution, sudo. Sudo stands for super user do. It allows a user to execute a command with elevated privileges temporarily. So for example, you want to do sudo app update. You want to update your applications. What just happened? A user remains a regular user, command runs with root privileges, and access is only temporary. Because instead of giving someone full control, you give them control monetary power. So root is the master key to the building, and sudo is temporary access badge. Right? Sudo versus sudo, su versus sudo in the exam in the real world, right? Definition, switch user off into root, right? So you do su space minus, right? What just happened? You become a root. You stay root. Every command is dangerous because once you're root, there is no boundary anymore. Su is full role switch. Sudo, sudo, is single command elevation. For the CompTIA exam, you want to understand that least privilege is always preferred. Now go deeper. Every file and directory in Linux has 3 levels. Owner, the user who created the file. Group, a set of users with shared access. And others, everybody else. Each level has 3 permissions: read, ability to view the contents; write, ability to modify contents; and execute, ability to run a file like a program or script. So if you look at it at the visual structure, you'll see something like RWX, right? So break it down. RWX is owner permission. Well, I'm going to read the whole thing, right? Because you're going to see it in lines of 3s, right? So you're going to see, for example, RWX R dash X R dash dash, right? Let me repeat it. RWX R dash X R dash dash. So what does it mean? RWX, which is the first 3 sets, that's the owner, right? It's telling you that the owner has read, write, and execute permissions. R dash X means it's group permission and they have read and execute power. And then everybody else just has read, right? Owner has full control, group has read and execute, and all others just read only. Why does this matter? Because this line answers who can touch this file and how. They have what they call numeric or octal permissions, right? So read gets a value of 4, write gets a value of 2, and execute gets a value of 1. So if you're doing RWX, that value is 7. If you do R-X, that value is 5. And you do just R, that value is 4. So when you do chmod 754 on file.txt, what you're really saying is owner is 7, which is full, group is 5, read and execute, and others are 4, read. Why does technicians use numbers? Because numbers are faster, precise, and scriptable. chown changes the owner of a file. For example, chown user1 file txt. Ownership determines control. Wrong owner equals wrong access. A website fails. Why? Because the file belongs to the wrong user. The result is server cannot read the file. The website breaks. Fix chown www-data space file.txt. Permissions behave differently for directories. Read, list contents; write, add and remove files; and execute, enter the directory. This is a critical insight. You can have read but not execute, see the names but not enter; have execute but not read, access files if you know the names. Why does permissions fail in real life? Most common issues is either wrong ownership, missing execute permissions, or overly restricted settings. So a user comes to you and say, I can't open the file. You check, right? ls-l, right? Then you just see ... file.txt. No permissions were given. So you go chmod 644 file txt, right? Read, write for the owner, read for the group, and read for everybody else. You always, even in Linux, you always want to follow the doctrine of least privilege. Least privilege means users should only have the minimal access required to perform their task. Why? Because this limits damage, reduces attack surface, and prevents accidental mistakes. Instead of giving full admin access, you grant specific permissions. Now that you understand something deeper than commands, you understand control is not about access. It's about boundaries. You know now you know what users are in Linux, right? Why they exist, right? Why you need them, right? And why root exists. Why sudo is safer than su, just regular su. How permissions define control, and how ownerships impacts the systems, right? So I'm going to make this a 2-parter. So this is going to be part 1 of Linux, right? Because you need to know a little bit about Linux on the CompTIA 1 exam. I know Linux frightens a lot of people. You know, it's one of these things that, I don't know enough about it to be able to, to say I'm an expert at Linux. But you don't need a lot. You just really need to know the basics: the read, write, execute, right? The 764, right? That example that I gave you, ls command, right? Remove, rewrite. You don't need. There's not a lot. This is not a Linux exam, right? Actually, CompTIA actually has a Linux command, a Linux test, a Linux Plus, and it's actually 2 exams, like the A Plus. So if you're really, really interested in Linux, take that exam. I'm okay with Linux. I'm not a Linux expert. I probably will never take the Linux Plus exam, but we'll see what happens. But this is part 1 of the Linux commands that you're gonna need for the CompTIA networks. But don't be nervous. What you could do is install Oracle VirtualBox on your PC and then download a copy of Linux and then have it installed virtually. That's one thing that you can do. If you have Windows Pro and you download, I think you have to download a version. I don't think so. I think if you have Windows Pro and you go to Hyper-V and you do create, if you go to Hyper-V and you do quick create, I think one of the things that allows you to install is a version of Linux, Debian, the Debian version. So I'm just looking it up in my system now. It's a quick, easy way. Ubuntu. So a quick, easy way to install it. You don't need VirtualBox. You don't need to download the ISO. I think if you don't, but the thing is, you might need the ISO in order to install it. I'm not 100% sure, but I don't think you need it. You might. I got a lot of stuff on my computer, so I can't really test it because I would have to start deleting stuff, which I'm not going to do. But I think if you go to quick create, if you go to Hyper-V, right, do quick create, it on the right hand side where it says actions, you should be able to install a copy of Ubuntu on your PC, and it will be a virtual Ubuntu. But you have to have Windows Pro. If you don't have Windows Pro, if you have Windows Home, you're not gonna be able to do it. So you gotta have Windows Pro. I mean, there's a way of doing it, of installing Hyper-V. If you only have Windows Home, there is a way of doing it. You have to look for it on the internet. I don't advise you doing it unless you know what you're doing. I actually have it. My laptop is home, and I actually installed it. I looked it up on YouTube. There's a video on it on YouTube. And I have it. The only thing is that if you upgrade, anytime you upgrade your PC or you update your PC, right, when Windows says, oh, we have an update for you, it will automatically remove that, and you have to go and do it again. So that's the only bad thing. But if you have Windows Pro, it's seamless. So there's my advice for you if you want to learn a little bit about Ubuntu and play around a little bit in the Linux environment. Again, it's not the end of the world. They would ask you maybe 4 or 5 questions on the CompTIA exam. I think total in both, you're only gonna get 4 or 5 questions. You're not gonna get like 20 questions on Linux. You're not. You will get some, but simple questions, not anything radical. All right, that's gonna do it for today. We'll do part 2 on this next week. Also want to remind everyone with Mother's Day quickly approaching, a great Mother's Day gift will be my book, Scam Proof for Seniors: How to Recognize, Avoid, and Stop Scammers, right, from scamming your mom, your dad, your grandparents, right, your aunt. It makes a great Mother's Day gift, with Mother's Day being around the corner. You can buy it at Amazon.com. Just type Scam Proof and my name, Juan Rodriguez. As of this date, My book is number 38 on the social media books that are out there on Amazon. And you can also buy directly from me, Professor JRod, JROD.com/books. And you can buy it either paperback, or you can do a Kindle version or PDF version if you want. Download it directly to your PC. All right, that's going to do it all for me today. Thank you very much. And we'll see you next week for part 2. And remember, Professor J-Rod, and keep tapping into technology. This has been a presentation of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J-Rod, that's J-R-O-D, or you can email me at ProfessorJRod, J-R-O-D, at gmail.com.